All right, welcome back, chemistry students. Today we're going to be looking at figuring out theoretical yield, actual yield, and percent yield, and using a little bit of stoichiometry too to find our percent yield. But it's mostly figuring out what is our percent yield. So the actual yield is the mass of product that actually forms in an experiment. It is generally less than what you expect. Okay. Your theoretical yield is what you should get if you ran your experiment flawlessly, if there was no human error, if you didn't lose any mass in any of your steps. So it's like what you should get, but we know that experiments are not always perfect, so your actual is generally less than your theoretical. So if you take your actual yield divided by your theoretical yield and you multiply it by 100, then you'll get your percent yield. Okay, so like if I set up an experiment where I mixed 5 grams of iron with 5 grams of sulfur and 5 grams of salt, and I made this mixture, and your guys' task was to separate the mixture, maybe by taking a magnet and getting all the iron filings out. And if you measure that, you try to get to 5 grams, but you're going to notice that you're always going to be a little bit short. Or maybe in a weird case, you get a little bit more. Maybe there was some residue left over from a magnet, or whatever. Maybe you didn't measure precisely, but there's always errors when you are doing, or when you get your actual yield. So let's do some problems here. Okay, looking at dichloride monoxide right here. Used as a powerful chlorinating agent in research, it can be produced by passing chlorine gas over heated mercury oxide. So if we add these two together, then we will get dichloride monoxide. So we're looking at what's the percent yield. If the quantity of the reactants is sufficient to produce 0.86 grams of ClO2, but we only get 0.71 grams obtained. Now this is a really simple equation, okay? Actual divided by theoretical times 100. This is a very simple sample problem, but you guys know me, I'm going to take it up a few notches here soon. So this is what we got. This is our actual. This is what we were supposed to get. This is our theoretical. So really, you're just going to take your actual divided by your theoretical. Okay? So let me grab my pen here. Make sure I have a pen. Okay. So this is my actual, and this was my theoretical. All right. So actual is 0.71 grams divided by my theoretical, 0.86 grams times 100. All right. So you punch it in a calculator, and you get 82.6%. That's it. Pretty simple. Let's look at another sample problem. Looking at quicklime, prepared by roasted limestone according to the following reaction. When 2,000 grams of calcium carbonate is heated, the actual yield of calcium oxide is 1,050 grams. What's the percent yield? Okay, now this one, I'm going to take it up a step. You got to do a little bit of stoich, okay? So they give us the actual, which is nice. And this is the reactant that we started with. And we want to get to CaO. So I'm going to have to use a little bit of stoichiometry to get to CaO. So you start with what you're given. 2.00 times 10 to the 3. Well, if I move the decimal place over 3 places, I actually have 2,000 grams of CaCO3. Now I got to convert this to CaO, and I got to get it to grams because they give it to me in grams. So I'm going from grams to grams. Well, to get from grams of calcium carbonate to grams of CaO, I got to convert this to the mole, so I can use the mole ratio. So let's figure out the molar mass of CaCO3. So I can get to moles of CaCO3. So calcium, if I look on the periodic table, I have one of them at 40.08. Carbon, I have 1 of them at 12.01. Oxygen, I have 3 of them at 15.99. So I add these all up to get my molar mass of CaCO3, which is 100.06 grams. So that's going to go on the bottom because I'm in grams, so grams goes on the bottom to cancel out. So if I were to measure out 100.06 grams of CaCO3, that is equivalent to 1 mole of CaCO3. So now I'm in moles of CaCO3, and I can use mole ratio. Now my chemical equation here is balanced, and everything's a 1-to-1 ratio. So I'm going to go from 1 mole of CaCO3 to 1 mole of CaO. But I can't leave my answer in moles. I got to get to grams because I want to compare the grams at the end here. So what's the molar mass of CaO? Well, let's figure it out. So I got calcium 1 at 40.08 and oxygen 1 at 15.99. And I add these up and I get 56.07 grams. So that goes on the top here, 56.07 grams of CaO, and I just multiply across. 2,000 times 1 divided by 100.06 times 1 divided by 1 times 56.07 times, divided by 1 gives me a pretty big number here. 1,120.7 grams of CaO. Now, what I just calculated was my theoretical. So if I ran this experiment flawlessly and there were no errors whatsoever, then I should get 1,120.7 grams of CaO. But that's not the case because my actual yield was less than that. I only got 1,050 grams of CaO. So they're asking what's the percent yield. Remember what percent yield is? Actual divided by theoretical. Okay, actual divided by theoretical times 100, right? So my actual 1,050 grams divided by my theoretical, this is my theoretical 1,120.7 grams multiplied by 100, and I get like 93.7%. There we go. There's my percent yield. Okay, let's look at another problem here. The percent yield for this reaction is 83.2%. What mass of PCl5 is expected from the reaction of 73.7 grams PCl3 with excess chlorine? So here, I'm just write the equation. Okay, remember it's percentage yield equals actual divided by theoretical times 100, right? So here they give us the percent. Okay, they gave us 83. Holy crap! Never mind. I'll just set it over here. 83.2% equals what mass of PCl5 is expected. So we need to figure out your theoretical. That sounds like a theoretical. From the reaction of 73.7 grams PCl3 with excess chlorine. All right? Okay. I'm missing something here. What am I missing? Oh, okay. Sorry. I was just having a moment there. All right. So let's start with our reactant, right? PCl3, and let's get to PCl5. So we're going to do a little bit of stoich. 73.7 grams of PCl3, and I got to get 2 grams of PCl5. So let's figure out the molar mass of PCl3. Phosphorus, I have 1 of them at 30.97, and chlorine, I have 3 of them at 35.45. And I add them up together, and I get a molar mass of 137.32 grams. So I'm in grams of PCl3. Molar mass of PCl3 is 137.32 grams. That's equivalent to a mole of PCl3. Okay, so I'm in moles of PCl3. I can use the mole ratio to go from PCl3 to PCl5. This equation is already balanced, so it's a 1-to-1 ratio. So 1 mole of PCl3 to 1 mole of PCl5. And now I got to figure out the molar mass of PCl5. So I put 1 mole of PCl5 down here. Let's find the molar mass of PCl5. So phosphorus, I have 1 at 30.97. Chlorine, I have 5 at 35.45. And I add them all up together. And I get a molar mass of around 208.22 grams. So that's going to go on top. All right, so I multiply across. 73, let me get my calculator here. 73.7 divided by 137.32 times 1 divided by 1 times 208.22. And I get 111.7 grams of PCl5. Okay, so this is my theoretical. Okay, so my equation, actual divided by theoretical, so this goes down here. I forgot the times 100 part. So we are solving for x. What's our actual yield, right? How much can we actually expect with an 83.2% percent yield? So to do this, let's just divide by 100, right? Get rid of this. So 83.2 divided by 100 is 0.832. Okay, and then to get rid of 111.7, just multiply by the reciprocal, right? So that will cancel out. So then take that times, and you should get around 93 grams. So 111.7 times 0.832 is 93 grams of PCl5. So there's my answer right there. All right, one more sample problem. Okay. Determine the limiting reactant, theoretical yield, and the percent yield if 14 grams of nitrogen gas are mixed with 9 grams of hydrogen gas and 16.1 grams of an H3 form. So first off, let's find our limiting reactant. I think we've been using method 1 the most here. So method 1, you pick a reactant and get to the other reactant so you can compare the values at the end. So I'm just going to start with the first one that they listed. Why not? 14 grams of nitrogen, right? Nitrogen gas. So I have 14 grams of N2, and I want to get to grams of H2 so I can compare this value. So the molar mass of N2, 2 nitrogens at 14.01, is 28.02 grams of N2. That's equivalent to 1 mole of N2. So now I'm going to use the mole ratio, and this is balanced. So I'm in moles of N2. If I look here, there's a coefficient of 1 there. 1 mole of N2, 2, I'm going to hydrogen gas, 3 moles of H2. Now we got to go from moles of H2 to grams of H2 by multiplying by the molar mass. Well, I'm in moles, so that means 1 mole will go on the bottom. What's the molar mass of H2? Well, hydrogen, I have 2 of them, each at 1.01. So the molar mass of H2 is 2.02 grams of H2. So I multiply across 14 times 1 divided by 28.02 times 3 divided by 1 times 2.02, and I get 3.02 grams of H2. This is what I need. This is what I was given. I was given more than what I need, so H2 is actually our excess. So to answer our first question, our limiting reactant is actually N2. All right, now we need to figure out our theoretical yield and the percent yield. So this right here, this is our product. This is our actual yield. Okay, so I got to convert N2 to NH3 to figure out my theoretical. So, just block this off here. Start with what you're given. I have 14 grams of N2. And I got to get to grams of NH3. So to do that, I got to multiply, or actually divide by the molar mass of N2. So very similar to what we just did above. That's equivalent to 1 mole of N2. Now I'm going to use the mole ratio, and I'm going from N2 to NH3. So I'm in moles of N2. I look up my chemical equation, 1 mole of N2 to 2 moles of NH3. I'm in moles of NH3, but I got to get to grams because it's in grams here. So 1 mole of NH3 is how many grams? So nitrogen is 14.01, and then I have hydrogen each at 3 hydrogens each at 1.01, and the molar mass of this is 17.04. So that goes on the top here. Punch this into my calculator. My theoretical yield, because this is what I was actually calculating, my theoretical yield, 17.02 grams of NH3. But so I just figured out my theoretical yield. There's my second part of my answer. And the third part is, what's the percent yield, right? So I'm going to extend my page here. Percent yield, remember, is actual divided by theoretical times 100. So my actual was 16.1 grams divided by my theoretical, 17.02 grams times 100, and I get 94.6%. And there's the third part of my answer. Okay, so that concludes Chapter 9, Stoichiometry. You guys do have an exam. This exam, you'll have to do one problem of each. So we started with mole ratio. So you'll have a problem with just, mole ratios. Convert a mole of one substance to moles of another. And then we went from moles to grams. So your second problem will be, moles to grams. And then you'll go from grams to moles. And then there will be a problem where you go from grams to grams, or mass to mass. And then there will be a problem where you have to find your limiting reactants. And the final problem will be a percent yield. Okay? So you'll have 6 problems, and then the rest of the test is just 10 multiple choice questions. This exam will be timed. I will unlock it at around right before 11:30. Right before 11:30, and it will be due 12:30. And any late submissions will be docked like 20%. Okay, so that does it for Chapter 9 Stoichiometry.